Next speaker is Mateusz Malenta. He is a software engineer at the University of Manchester, and he's going to talk about using Docker in a radio astronomy environment.
Okay, perfect. Thank you very much. Thank you for having me. So as the title says, I'm going to talk a bit about, how we use Docker and mainly, how we shouldn't maybe use Docker. And, as I'm saying, if someone wants to work with me and add an extra logo down at the bottom, there's also, Meerkats are relevant. Our team, Meertrap, we are using Meerkat telescope. So that's why you see Meerkats there. So scope of this talk, it's not going to be a general container talk, as is already in the title. I focus on Docker. It's sort of intermediate level, so I assume you have a bit of a Docker knowledge, but also, if you're a Docker guru, if you're the only person responsible and your main job within your institute or within your group is doing Docker or containers, you will know this stuff. And I'm mainly focusing on problems that are caused at the very, very first stage of us interacting with Docker, that these problems can cascade. So problems with inefficient builds. And at the very end, once you have a build, then you have the perfect build. How do you actually, distribute it? And in this case, how do you distribute it using a private registry? So we, as scientists and astronomers, we have a very complicated relationship with Docker. This kind of sort of love-hate relationship. We love to hate it and hate to love it, really. We use it, but we wish that sometimes we didn't and that there was something better. Main thing that I usually say is Docker was designed really for the web when it was released. And, comparatively, our scientific applications are much more complex than, most of the examples that you see on the web, running simple Node.js or Apache servers. A lot of the stuff, we have multiple applications that have to work together, that sometimes might not be used the one container, one process approach. We have used external libraries. Yesterday, during the reproducibility BOF, we talked about, a lot of problems with using libraries, the libraries changing. And we make heavy use accelerators like GPUs. And quite famously, it was just added on top of Docker, pretty much like as an afterthought. And recently we've had a lot of talks, machine learning, that can be quite heavy, consuming. And when you combine all of this with the standard Docker philosophy and mainly what is taught on how to do proper Docker images, your images can get quite big, slow, and because of that, fairly difficult to maintain. So just to give you an example, one very, very common mistake that I see, very often, standard approach, you've got your very simple Docker file, you have your base image, this case Ubuntu, and you want to install Git. And you want to clone a repository that you want to use for something. In this case, I'm just cloning the repository that I have for some tools. And then you say, well, I don't need Git anymore. I'm going to remove it. So you install the Git, you clone your repository, and then you remove Git. All is great. You start your Docker. After you build it, your repository is there. You type the Git and Git command not found. You cannot access it, so all is happy. But then you compare the image sizes, and you end up with the same size. Even the opposite. Your Git remove became slightly bigger than when you keep Git. And you start thinking, well, what is going on? I cannot access it. I told the build to remove it. I cannot access it. So what is actually going on? Well, the problem is that you separated it into two layers. And what is happening? You install and remove it in different layers. So you cannot access it and you know, it's still, but Git is still there. And I know it may be quite counterintuitive, but this is something that we've been used to for years, if not decades, with version control. If code gets you know, updated and you pull new code, some files might be deleted. So at the very moment in your repository, local repository, you cannot access it. But the moment you check out an earlier repository that still had this file, you can access it with no problems again. So and then Docker layers kind of work in a very similar way, by applying difference on top of an extra layer. So that's why you can have situations like we have here, that actually your layer grows bigger, even if you know, potentially remove things. So why is that a problem? Well, Git is quite small, so why should you really care? Well, not everything is small. One thing, compilers are not small, development libraries are not small, and they all can add up to gigabytes. And that also causes a security issue. So one thing you should definitely not do, but definitely not do inside the Docker, you know, but some of us do it, use a file with login information and, you know, remove it in a different layer. And you think, okay, it's secure, it's not accessible. The problem is the moment you make it publicly available, and, you know, very often we make stuff publicly available through Docker Hub, this file, it's still in the final image and everyone can see it. And you may say, okay, well, who would look at it? But, you know, silly things like I've been on some projects that after 2 or 3 years, all of a sudden we start getting messages on Slack from random people that have discovered our Docker image on Docker Hub, and the Docker image has embedded you know, Slack authentication token that we used for notification bots, for example. And, you know, technically it was removed, but it was still embedded in some lower layers. So this is definitely, you know, if size is not a problem for you, but it should be, then it's definitely a security issue. And that happens more often than you can imagine.
4 minutes, Mateusz.
Yep. So the thing is, you know, you can do it in different layers, but it can get cumbersome. So imagine, you know, you do it multiple times. You've got different Git repositories, and, you know, everything is happening technically in the same layer, but, you know, can be impossible to detangle. So in the past, there used to be so-called builder pattern, when you would maintain 2 Docker files and, you know, have some extra scripts to build and extract relevant parts, copy them from development to production. I personally didn't like it. For the past 3 years, we have multi-stage builds. So you have single Docker file, and you can use multiple from keywords. So you first build something, and then you just copy a relevant part to your final Docker. So I have a stage called downloader. I, you know, have everything downloaded, installed, and then I just put it into relevant part. And as you can see, when I use a multi-stage build, I remove everything. There is no Docker, no remaining libraries, no X11 that Git installs. So that's one of the heaviest things with Git. It installs whole X11. So even with a simple Docker, you already save 100 megabytes just by using a proper build solution. Additional problem, you know, there is a thing a lot of people don't really care about. It's context. So whenever you start building your Docker file, you have to specify context. Most commonly, you build it on your current directory. And a lot of the time I see it, you know, context is built sometimes within a very complicated project. There are many the Docker file is in the root directory of the project, and some child directories. They have, you know, sometimes tens of thousands of machine learning examples, a lot of heavy files that, you know, sum up to tens of gigabytes sometimes. And the problem is Docker engine, when you start the build, includes it in your context, because Docker is like, okay, you might want to have an access to all of these files. So you can see a simple thing, just pulling an Ubuntu image, if you have a clean context, takes like 0.2 seconds. The moment you have 10 gigabytes in your context, it takes 3 minutes, so increases your build times. And that also uses your disk, because that has to go in some temporary space.
2 minutes, Mateusz.
Yep. So one main thing is, you know, use only what you need. separate development and production images with Docker, with multi-stage builds, and never ever, there are official images, but never trust them. Because, for example, just to give you an example, an NVIDIA image can install a lot of the stuff that you don't need. I just want to run a simple kernel on the GPU. I might not need, sparse libraries, linear algebra libraries, or deep learning network libraries, and never, ever use the latest tag, because that just changes and can change and can, have problems. And definitely experiments. Some things may surprise you. For example, NumPy version on Conda, NumPy package, uses maths Intel MK library, and it's 200 megabytes heavier than pip. If you don't need it, these things keep on adding up. So again, you have the perfect image. You might want to put it in private registry. Why would you bother? A lot of the time we rely on Docker Hub these days, but there are a lot of changes. So there are experiments with the retention policy that's paused for now, but also with the amount of pulls, 200 pulls every 6 hours. Problem if you're developing something across a large cluster. That's why you might want to put it in private registry. Technically, it's simple, but as I've already said, nothing in Docker is simple. You've got your registry running, you are happy, keep on adding images for months, weeks at a time, and all of a sudden you run out of disk space. And official advice is, well, just add more disk space, And the problem is there are not really actual CLI tools to help you manage the registry. You better like the REST API and quite complicated ways of getting, information from the registry. First you need your full repo name. You need to get a manifest. From that manifest, you need to get a digest. You need to delete the manifest. You need to run garbage collector, and then keep your fingers crossed, hope for the best that you didn't break anything. You didn't really miss anything. So that can become very, very complicated. And as I said, there are no CLI tools. So, you might want to write a script. And this is the script that, for example, we are using for managing our registry. That is 200 lines of Python code, just to pretty much manage adding, containers into the registry and then removing them properly. So even though, it is useful, it can become very, very problematic. So that was just, a very quick overview of some of the things that, as I said, can cause problems. And there are very, very common problems with Docker. There are many more. And hopefully, my hope is that, thanks to the meetings like that, we might actually come up with some good specifications and maybe community guidelines for everyone, for scientists and astronomers to actually follow, that we actually can solve a lot of things that and avoid many traps that are out there in containers in general. Thank you.
I see there is a question. Great talk with great tips, says Walter. Is there a GitHub with your script?
No, I will put it on GitHub. It's currently on our private GitLab. So I will put it maybe after today. I will put it into the GitHub, and I will post a link to make it available.
Okay, thank you.